Our last topic here for this chapter on regression is looking at the coefficient of determination. So the coefficient of determination is going to try and help us determine how useful our model is. And so you'll notice the notation here, the symbol that we're going to use for coefficient of determination is r squared. As a reminder, correlation that we just learned was r. And literally we are taking that correlation value and squaring it to get the coefficient of determination, r squared. And so what we're told here is that the coefficient of determination is expressed as a percentage. R was not, but r squared is. And it's representing the percentage of the total variation in your y variable that is explained by using the x variables that you used in your model. R squared has to be between 0 and 1. Remember, r was between -1 and 1. And so any of those negative values that we squared would become positive. So r squared has to be between 0 and 1. And it's commonly used to describe this success of the regression in explaining the response variable y. So the higher the percentage, the more successful our model is. Okay, so if we go back to our data set on years of education and annual income, we had just entered the data into the calculator and gotten the following output from the calculator. So where that came from was we went to Stat Edit, we entered years of education in list 1 and annual income in list 2. So our x values in list 1, our y values in list 2. And then we went to Stat, Calculate, and chose option 4 for linear regression. Hit enter all the way through. We got our regression equation, we got our coefficient of determination r squared, and we also got our correlation r. So what we're asked for in this example is to find r squared. So find the coefficient of determination. So that's 0.9487 if we round to 4 decimal places. And then also asked to interpret what that means. So our interpretation, remember, we're going to express r squared as a percentage. So to convert to a percentage, we multiply by 100 and we get 94.87%. That's really good. That'd be a really good model. So what we're saying is that 94.87% of the variability, in our y variable, which was income, annual income. So we know that annual incomes vary from person to person. And what we're saying is that 94.87% of that variability in annual income is explained by including number of years of education in the model. And so what we would say is that that's a very, very good model, right? So the closer that percentage is to 100%, the more useful our model is for trying to make predictions of our y variable, which in this case is annual income.